All right, ladies and gentlemen. So last time we did greatest common factors. And if you remember, factors are numbers that you multiply together to get the number they gave you. This time we're doing something called least common multiples. So if I had 5 and 10, and we were doing GCF, which is greatest common factor like we did last time, we would be looking for the numbers that go together. So 1 and 5. 1 and 10 and 2 and 5. And so we would be looking at these numbers. These are the factors. These are the numbers that we multiply together to get this number. Well, with least common multiple, so now we're looking at LCM, least common multiple. If I had a 5 here and a 10 here, now I'm not looking for the numbers that this multiplies together. I'm looking at this times 1, times 2, times 3, 15, times 4, times 5, times 6, and so on. Okay, so 10 times 1 is 10, times 2 is 20, times 3 is 30. Okay, I'm looking for what are the multiples. Here's 40, 50, 60. Okay, now instead of looking for the largest one, which like for 5 and 10 would be 5, for least common multiple, I'm looking for the smallest one smallest multiple that's common to both of them. They both don't have 5. They both do have 10. So 10 is the smallest or the least common multiple. Now, also look that there's 20 and then there's 30. If we kept going, there would be 40 and there would be 50. But 10 is the smallest one. So the least common multiple for 5 and 10 would be 10. So it's like greatest common factor, but it's least common multiple. So instead of the pairs that make this number, it's this number times 1, times 2, times 3, times 4, times 5, times 6. That's multiples. Okay, it's like a multiplication chart. The multiples are this number times 1, this number times 2, this number times 3, this number times 4. That's multiples. It's a multiplication chart. So if we start here and we look at number 3, because that's where we're going to be starting, let's look at that. It gives you 3 and 7. So I like to write them on lines like right above and below each other. And then I just like to do it in my head. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. And then 15. And then 18. And then 21. And I could probably stop there. I don't know, but let's see. One thing that helps too, if you have graph paper, this actually works better on graph paper because I like to keep the multiples together. So here is like me making a cheap little chart here. So this would be 1, 2, 3, 4. I don't have to write the 5, 6, 7. I don't have to write the numbers up here. I just need to keep them kind of lined up together. So 7 times 1 would be 7. 7 times 2 is 14. 7 times 3 is 21, 28, 35, 42, 49. Okay, now I'm looking for the smallest one that is common to both of them. It's not 3 because this one's 7. So it has to be at least 7. So it can't be 6 either. 9, no, that doesn't match. 14, no, that doesn't match. 21, there they are. So sometimes you got to keep going, like 8, 9, 10, 11. Sometimes you need to keep it going, but this time I could stop at 7. So 21 is the one. So the LCM equals 21 for 3 and 7. Usually I like to circle it, but this one's kind of hard. It looks kind of goofy because they're so far apart in the chart, but I can just write it over here. So I could write LCM equals 10, and that makes it really kind of obvious what the LCM is. So that's how you do it. This one they said use a Venn diagram. It's the same thing. I mean, here's the circle, here's the circle for 3 and for 7. So I would have 3, 6, 9, 12, 15, 18, 21, 7, 14, 28, 35, 42, 49. 42 would probably go here. I'm thinking if I kept going, 21, 24, 27, 30, 33, 36, 39. Yeah, 42. So 42 would go here too. If I would have kept going with the 3, Um, the Venn chart, it works, but it's kind of like you got to make a list anyway. So like I like to make this kind of a list instead of the Venn chart. So if you decide to make just a list like this instead of the Venn chart, that's okay. I'm not going to be a stickler for using the Venn chart because you're going to have to make a list anyway. So let's look at the next way. It says find LCM numbers using a list of multiples. Okay, so this is the chart that I showed you before. Let's do number 7. So here's number 7, and the two numbers are 3 and 4. So I'm going to draw my little fakey chart here. There's 1, 2, 3, 4, 5, 6, 7. I'll go 8. Okay. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. 3 times 6 is 18. 3 times 7 is 21. 3 times 8 is 24. Okay. 4s. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. Then 24. Then 28. Then 32. If I kept going here, I would end up with 27, 30, and 33. So I wouldn't 33 doesn't go. I thought it would, but it doesn't. All right, so let's look at this. What is the least common multiple of these? It's not 3, it's not 4, it's not 6, it's not 8. Oh, it looks like it's 12. So 12 is the least common to both of them. So least common is 12. Okay. All right, and that's how you're going to do 6 through 11, and then let's look at number 13. And this one, once again, they want you to do prime factors or factor trees. So I'm going to put a 12 here and a 27 here, and I'm going to do use LCM of the numbers using prime factorization. Hold on a second here. LCM of 14, 4. Here it says write the prime factorization for each number. Circle each different factor where it appears in the greatest number line. So for 4, it's 2 and 2. For 15, it's 5. And for this, it's 3 times 3. So 2 times 2 times 5. This makes no sense to me whatsoever. So the LCM of 4, 15, and 18 is 180. Why did they choose both 2s? Why did they choose a 5 and not the 3? And why did they choose 2 3s? Circle each different factor where it appears the greatest number of times. Oh, greatest number of times? 5 appears here only, so circle 5. Here it's, okay, so, okay, that makes more sense. So if we look at 12, this is 3 times 4, this is 3, and this is 2 times 2. So we're going to use these 2's because they appear the greatest number of times. 27 would be 3 times, let's see, 2, 3, 4, 5, 6, 7, 8, 9. So 3 times 9, here's 3, and then 9 is 3 and 3. So I'm going to use all 3 of these. So it would be 2 times 2 times 3 times 3 times 3. So 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is 24, 36. And 36 times 3 is, I have no idea. So let's bust out the calculator here and let it help us out. All right, so let's just do it. 2 times 2 equals times 3 equals, got that right so far. Times 3 equals, got that right so far. And then we got one more 3, times 3 equals. So it's 108. 108 is the least common multiple. LCM equals 108. All right, so for these problems where it says use prime factorization, try your best to do this way, but if it doesn't work for you, they're just trying to have you explore different ways of doing it. If you find this like crazy and hard to understand, because I find it crazy and hard to understand, if you just make this list up here, if you just make one of these, that's okay. Now, beware, with larger numbers, these lists can go multiple rows. They can just keep going, because this is 108. So I might have had to go like way out here and maybe even started another row. This does make it a little easier and a little quicker, but this to me, my brain wraps around this more. It helps me be able to kind of lay it out and see it a little bit better. So if this works better for you for 12 through 17, that's okay. All right, so we're doing 3 through 20. So you are going to do these three as well, and I'm not going to go over those because I'll end up answering them for you. All right, ready, set, go.